All right, I'm sorry I'm not with you guys, but here we go. Here's what we're going to do. So, we are going to look at reviewing solving quadratic equations over the set of complex numbers. We're going to look at how you solve, just really quickly, but more importantly, how do you check complex solutions? I mean, really, you plug it in and see if it's true, but I'll show you. Then we're going to look at how do you write the equation if you have the solution. So how do you work backwards? And we're going to look at how you do it with real number solutions and how you do it with complex number solution. And then finally, we're going to end with factoring any quadratic expression into linear factors. So let's go through it. By the way, as I go through this, I still encourage you guys to write down your own notes. It's always good. The studies show that if you write the notes, if you're actively involved like that, you tend to remember the notes better. You can definitely shorten them if you want. I put a lot of description in here because I'm not there with you guys, but definitely shorten them. Pause the video. This is your video, so use it as you need to. Okay, let's do it. So first of all, let's review solving the quadratic equation over the set of complex numbers. So this means if we ever start taking a square root of a negative, we can still keep going. Um, so if I was going to solve this blue one, now at first I notice a isn't 1, so I'm thinking completing the square may not be the best, but then I notice if I divide everything by 2, I can make a 1 and b will still be even, and that's when completing the square is super easy, so I'm going to go for it. I divided everything by 2 to rewrite the equation like this. Move the 5 over to the other side, made it negative 5. Completed the square by taking half of this. Half of 2 is 1, and 1 squared is 1. So I add 1 onto both sides. I can factor and solve. And then I take the square root. And remember, the square root of something squared with a variable is always the absolute value. And I'm taking the square root of a negative, but we know how to do that. It's automatically going to have I in the answer. And the square root of 4 is 2. Then I can remove the absolute value by putting plus or minus, and then finally get the x by itself by subtracting 1. Yay! So that's all we mean by that. But how do you check solutions? So what if I was going to check these solutions in this equation? Did I actually get it right? Well, you literally still plug it in. So here's the original equation. Always go back to the original. And I'm going to plug these in one at a time. So I'm going to plug in negative 1 plus 2i into this equation. So x is negative 1 plus 2i. This x is negative 1 plus 2i. Holy crap, does all that really equal 0? Well, yeah. Remember, I'm going to have to square this binomial. This is where you could set it up using the boxes if you want. If you know the pattern of squaring something, you can just write the answer. But when you square this, when you do negative 1 plus 2i times negative 1 plus 2i, this is what you will get. Then I distributed the 4 across here, and then I just had the 10. Now I'm distributing the 2, and just wrote everything else. And then I did a couple of things. The I squared, remember, is negative 1. So 8 times negative 1 is negative 8. But I also have a negative 8i and a positive 8i that cancel out. So I have 2 minus 8 minus 4 plus 10. Finally, something simple. And sure enough, when you add all those up, you really do get 0. So yes, 0 equals 0. This is true. Now, if you want, go ahead and pause the video and try plugging in negative 1 minus 2i and see what you get. I'm assuming you paused the video. Here you go. If you try it out, it still works. So if you need to pause the video to look at that, feel free. Otherwise, now here's one to try on your own. Definitely pause the video now. Give this one a shot, see what you get, and then check your answers once you get a solution. So pause the video. All right. B isn't even. I didn't want to use B, so I just went for the quadratic formula. Here's a quadratic formula, and here, I'll make it a little smaller. Well, actually, I guess it'll fit. Here it is. I got down to this. Here were my final answers. You can take a look at that to see what you think. But now I'm going to check them. And yes, they're fractions, but I still check them. So here's the first one, negative 5 halves plus root 3 over 2i. I'll let you just look at it. I let both x's equal that. Remember, I have to square this binomial. But it really does work. You do get 0 equals 0. So I'll let you check that out. And again, pause the video if you need to look at this. But then here's the other solution checked. They both work. So it gets messier when you have to check I, but you can still do it. All right, so there's that first topic. Next one. How do you work backwards? What if we are given the solutions? How do you write the quadratic equation? So first we're going to look at how you do it with real number solutions. Work backwards. Let's say I told you that x equals 4 and negative 1/2 were the solutions. So x equals 4 and x equals negative 1/2 were the solutions. Make each one of these equations then equal 0. And if you have something like this one where you got fractions, multiply both sides by the denominator so that you can have just integers. And then these are your factors, x minus 4 and 2x plus 1. And then if you multiply these together, you get this answer. So you're really working backwards. So I'll let you chew on that. And yeah, I wasn't sure if I had a you try. I guess I don't. So there's one example. Now, what do you do with complex solutions? Well, one thing to know, complex solutions always come in conjugate pairs. They always do. So if I gave you a problem like this and I said to write a quadratic equation and I told you one solution was negative 4 plus 2i, you automatically know it's conjugate. Negative 4 minus 2i also has to be a solution. And then we just go from there. I'll show you a little trick, though, that can make the math a little easier. But again, I set those up, x equals negative 4 plus 2i and x equals negative 4 minus 2i. Those are my solutions. And then I set each one of these equal to 0. So I add 4, subtract 2i, and add 4 and add 2i, and I get these. And then these are my factors. Now, I could just multiply these, and I could multiply these together using the boxes like we did in class yesterday. But there is a nice trick to save you from setting up the boxes and going through all that on this. We can actually treat this like a difference of squares problem. If we just think of it like this, I'm going to put, there's an x plus 4 in both quantity, and then we have a minus 2i and a plus 2i. So group the x plus 4 together, and then we have the 2i's. So this is your a minus b, your a plus b. So it's just a squared minus b squared. And then this is much easier to deal with than the boxes. You can totally do the boxes though if you want. I won't grumble at all about that. It's just a little more time consuming. So I squared this and I got this trinomial, and 2i squared is 4i squared. But remember, I squared is negative 1, so this is really like a positive 4, and combine these like terms and we get 20. So there it is. So you try this one. And again, pause the video, see how you do. All right, here's the solution right there. If 3 minus 7i is a solution, then 3 plus 7i, its conjugate pair, must also be a solution. So make these equations and then set them equal to 0, which tells you your two factors. Group the x minus 3's together. So here's your, oh my goodness, no, here's your a plus b and your a minus b. And then I just worked it out and got that. So yay. Okay, Let's take a look at the last thing. Factoring any quadratic expression into linear factors, even prime ones, even ones that we've said were prime. Now, when we factor anything into linear factors, we may not be using integers. We may involve I, we may involve radicals. So let's take a look. I mean, we know how to factor this. We can factor this. What adds up to 5 and multiplies to 6? 2 and 3. If I gave you something like this, you could try setting up the x. 2 times 3 is 6, and then you got 7. What multiplies to 6 but adds up to 7? 6 and 1. So you split that middle term, group, you get these. So we've known how to do that. But what if you had something that didn't factor using integer coefficients? Well, so here's how we can do it. Depending on the problem, there's different ways. So here's one way. Like if I gave you this one, we could try factoring it, but 2 times 4 is 8, and then b is 3. What two numbers multiply to 8 but add up to 3? Why, there's nothing. So we've been calling this one prime, and it really is, because we can't factor using integer coefficients. But sometimes it's still nice to be able to factor it. So what you do is consider solving this equation. So I'm just taking that expression and making it equal 0. Now what we're going to do is we're going to find the zeros to help us find the factors, but in order for that to work, the coefficient of x squared has to be 1, so I'm factoring out the 2. So I divide everything by 2. So I'm going to factor this, but this guy really would have the same zeros as the original. So I'm actually going to use completing the square on the original, and quadratic formula on the original, because I don't want to deal with the fractions in this formula. So I just put B, A, and C into the equation, and here are my zeros. So these are the two zeros. So if I make each one of these equations equal 0, I get this. This is a little awkward, have that minus and negative, but the negative's only on the 3, not the entire numerator. So basically, you can think of this as either factoring out a negative to combine with this to make it a plus, or negative times a negative is positive, negative times a positive is negative. But either way, if I change this sign, I'm going to change these signs. Same thing here. This gives me my two factors. So back to the original, remember that 2 that we factored out, we can't forget that one. And then we multiply these together, and there it is. We have factored the original. We're not actually solving, so I'm not saying x equals, I'm just factoring. So, oh, I guess before I have one for you to try. So feel free to pause the video if you need to. I'll make this smaller. Oh my goodness, what happened? Oh, I went to another. I closed it. Hold on a second, guys. It closed on me. I don't know what happened. I'll have to open this up. Now you can see how I organize all my stuff. Honors, polynomial, period 1. There it is. It's so weird. Here's the equation we were working on. So if you were trying to figure out, if you wanted to pause the video to take a look at what we did, I'll just pause. You can pause it and see it all at once. Before I have you guys try one of these on your own, let me show you, this was a trinomial. Let me show you a binomial, something like this. It almost looks like difference of squares, but it isn't, because it's a plus sign, not a minus sign. But we can rewrite it so it's difference of squares. Let me make it a minus sign, then the 49 turns into a negative 49. And then what do you square to get the first term? 3x. What do you square to get the second term? 7i. So a minus b, a plus b. So it's really easy when you got this. You hope for those. So now try these two on your own. Pause the video, and then we'll take a look. All right, here are the solutions. Here's the first one. So over here, I just did quadratic formula to get the zeros. But remember, don't forget that 3. He's important. And then there's the 2 factors. So pause the video, take a look at that if you need to. And here's the solution to the other one. And then that's the end of the notes. So yay, we're done. All right, hopefully this made sense. And if not, I'll try to answer questions when I come back. Have fun with the homework, and I hope you guys are being good to the sub. Thanks, guys. Bye.